Hello, this is Ibrahim Nassar with Ozone Engineering. In this demo, we'll show you how to import near-field data into ANSYS HFSS. Users may need to import fields whether calculated analytically, measured, generated by another tool, or received from a provider and use them as a realistic excitation to perform different type of analysis. To import near fields, the user would need two files, a file that contains the near-field data and a file .and, which is a descriptor file that describes basically the near field data and the location of the file and the number of files that you want to import. In this demo, I will be using this horn antenna design that was generated by the antenna toolkit to go over the process first of exporting the near field data and then import it and show you how to set up the simulation. To export the near field data, first, you have to create a near field setup by right-click on radiation here, insert near field setup, and then you have these options. You can calculate the near field on a line, a rectangle, a box, or a sphere. Here, we already created a near field rectangle. Here, rectangle 1. So once I select it, you see the area where I want to calculate the near fields is highlighted. So we want to calculate the near field on this rectangle. The user here can provide the size of the rectangle in the U direction and the V direction and the number of points that need to be calculated, and can specify the coordinate system to determine the location of this rectangle. So here it's defined to be at the bottom of the horn. And if we click OK here. Now to export the near field data, you can right click on the near field setup and select Compute Max Parameters. And now we can click on Export Fields. To export the near field and be able to import it, you need to change the file extension to .nfd. So the .nfd file will have the near field data, the location, and the near field values. And to be able, again, to import it, you need another file, which is the .and file. So if you don't have it already created, you can select here to export it with the near field data. And then if the users already have near field data, he can use this .and file and just adjust it to refer to the new file. So let's select Save and hit Yes. And we can click OK. Now let's open the files that were generated. Let's look first at the .nfd file. You can open it with an Excel file or you can open it with a notepad. So this is the NFD file, which again contains the near field data. It has the X, Y, Z locations. Then it lists the real and imaginary part of the electric field at the X location, then the Y location, then the Z location, and similarly for the magnetic field. It can also contain J, the electric current, the M, the magnetic current, and both of them can only contains electric field. It can also contain the magnetic field by itself. The second file that's needed to be able to import the fields is the .and file, which is again the ANSYS near field descriptor file. This is the format of the and file. It starts with this header here. Then you specify basically the type of the fields that you're importing. In this case, it's a near field data, NFD. And then you specify the fields that you are importing. In this case, we importing E and H, so we list it as EH. You can have E only, H only. You can have J for the electric current, M for the magnetic current, and JM for both of them. Then you specify the geometry. In this case, it's a plane. It can be a box, it can be a cylinder. Then you specify the center location. In this case, it's at the origin. Then you specify the size of the plane. So here it's 2.7 inches by 2.3 inches as we specified in the near field setup. Then you specify the normal directions of the field. So in our case, the horn is pointing in the negative z direction, so we can change this to -1. Then you specify the frequency or where the near field are generated at. Then you specify the coordinate system, if it's Cartesian or cylindrical or spherical. Then you point to the NFD file by providing the name and the extension. And in this case, since they both are located at the same location, so we don't need to provide the full extension. Now, let's go back to HFSS and import the near fields. To import the near fields, we can basically insert first an HFSS design by going to Project, Insert HFSS Design. So we inserted HFSS Design 1. To create a near field excitation, we can right-click on Excitations, Assign, and select Near Linked Fields. And in this case, it's a near field setup. In our case, we want to import external data, so we select External Data Design. You specify the coordinate system, where do you want the excitation to be located at, and then you click on Create Design. Here, we have to import basically the .and file. That is, this provide all the details we need for the simulation setup and refer to the NFD file that we need to import. So let's select the .and file. And then here we have the option to select the boundary type that is going to be used to simulate the near fields. So you have radiation option, a finite element boundary integral option, and the PML. So let's select radiation in this case. And we hit open. And we click OK. So as you see, HFSS has a script in the background, treats the AND file and creates a new design. In this case, HFSS Design 2. And has the simulation set up ready to simulate these near fields. So let's see what was created here. So it created geometry. Basically here, the red box we see, which basically describe the plane that we define. So if we open, click on create box, we see the size of the plane as we described it, and it provides some thickness to it. And also it created an airbox that encloses this plane with a radiation boundary to simulate. It also created the analysis setup with a solution frequency of 10 gigahertz, same as was provided on the .and file. So now let's simulate this file. And while it's solving, so we created the excitation on HFSS Design 1, here where we basically place the other geometry that we want to simulate with this near field excitations. So this is the near field excitations, which basically has a link to HFSS Design 2 to read the files from HFSS Design 2. So this design has the excitation that refers to HFSS Design 2 that has the near field data with the simulation setup to read the files from there. So now if we go back to HFSS Design 2, it has this excitation that basically reads the file that we specified here. So now let's look at the original fields in the horn design. So let's look at the 3D polar plot. Let's create far field 3D polar plot and look at the directivity and compare it to the imported data. So this is the 3D polar plot with a maximum directivity of about 13.15. And now let's see the simulated pattern of the imported near field in HFSS Design 2. So let's right-click on Results, Create Far Field Report, 3D Polar Plot, and let's select Directivity in dB and click on New Report. So as we see, the radiation pattern is similar to the radiation pattern generated by the original horn design. There's some delta to the directivity. This has to do with the way we exported the near fields, and it also can be adjusted by changing the settings in the analysis setup to improve the accuracy. We also see that the radiation pattern is pointing in the negative Z direction, as we specified that in the .and file here, since we have it to pointing in the negative Z direction. This concludes this demo, and thank you for watching.